Good morning, students. Today I am going to discuss about one of the important chapters in NEET and EAMCET, that is about current electricity. So this one we are going to discuss today, uh, and maximum I just going to give some of the basic problems in this case. Later we are going to see some of the questions which will be asked, which was asked in NEET examination and including EAMCET also. Okay, now see from this one, in case of NEET, they are ready to ask three questions. Usually, average questions asked here is three questions. From in this case, EAMCET they have asked two questions. Around two questions from here, 4 marks will be given for this one. So we just concentrate about current electricity first. Okay. In this case, first one, the number of electrons striking the screen of cathode ray tube, that value they have given 7.5 into 10 power 15 in 10 seconds. In 10 seconds, 7.5 into 10 power 15 electrons are incident on the screen of cathode ray tube. So this one we know about this one cathode ray tube. In case of in TVs and all, we used to see this one. See here in this case, so in this case, this is about the electron gun which can produce more amount of the electron. See what they have given in 10 seconds from here to here. There are more than 7.5 into 10 power 15 electrons are incident in 10 seconds. What they are asking in this case, what we have to calculate the electric current. That one we need to calculate in this case. Okay, now first one, see here, current. Current is, we call it as the flow of electron. That means flow. In this case we can mention with the help of the time. So I is equal to charge by time. See here, this is q is about the charge and divided by time. That is q is nothing but total amount, that is about the quantitatively we can measure this one, n into e. Here charge is electron and total number of electron, that is about the total charge they have given. Here is n number of electron, here is 7.5 into 10 power 15 into, this is about the charge of the electron, 1.6 into 10 power 19 and divided by 10. Now in this case, now you just cancel this one. This one is around 10 power minus 14 will come. The 10 will come over here, that will become 10 power minus 15. See here, 10 power minus 5 will come. If you multiply this one 7.5 and 1.6, what you are getting here is 12 into this one, 12 into 10 power 15. And this one, see all the answers what they have given in this case, all the answers are in see here, everything in microampere. So what we are getting here is 12 into 10 power minus 5. So we just multiply and divided by 10. What you are getting here is 120 divided by 10. 10 will become 10 power minus 1. So here is 10 power minus 6. What you are getting, that answer here is 120 microampere. So answer here is 120 microampere. Okay, now next one. In an hydrogen atom, a electron is revolving in an angular frequency. So what they have given here is angular frequency value they have given, that is about omega here. Omega is equal to 6.28 radian per second around the nucleus. Then the equivalent electric current is, what's that value? Equivalent electric current in 10 power minus 19. See here, these are all the four values. See everything they have given the value. So all the values in between 1 6 only the decimal is going to change. See from this one, first one, angular frequency here is omega is equal to 2 pi. See this one, 2 pi into nu, where nu is inverse of time is frequency. Nu is nothing but frequency here. Inverse of frequency here is, I just mentioned here, 2 nu divided by t. Nu is nothing but nu is equal to 1 by t here. So this one will come over here. So t is equal to 2 pi divided by omega. So from here 2 pi value is there and omega, this is about the angular frequency. 2 pi here is 2 into 3.14 is there. 3.14 divided by, already they have given the value 6.28. You just multiply both 3.14 into 2. What you are getting here is that value here is 1 second. Now this one, this is about the value here, 1 second. So current here is, already in the previous case we have seen current here is charge by time. So here is already, this is about the charge in 1 second. Previously we have seen about 10 seconds, that is total charge. Here is only the charge, flow of charge is current. See here current, The flow of electron opposite, see flow of electron direction is this one, opposite to the direction there is a current flow. So this is about I here, and this is about electron movement here. So charge by time 1.6 into 10 power minus 19 divided by 1. So what you are getting, that answer here is 1.6 into 10 power minus 19 ampere, remember. Okay, now next one, the current flow through a wire depends on time is, so they have given that they have given the current flow here depends on the time. They have given that value here is I is equal to 3t square plus 2t plus 5. The charge flow through the cross section of the wire. So in between time 0 to 2 second, what is the charge flow? See, current here is charge by time, already I told this one. So given value I is equal to 3t square, this one I just write on here. Current I is equal to, you just mention here, charge by time. A small change in the charge, I just mentioned here, dq by dt. So from here this one 3t square. Now substitute this value, see here dq is here and dt will go in this way. So this is about the current, right? I into dt. So here is dq by dt. So this one simply I just mentioned here, dq is equal to, I just mentioned here, this is about the current integration of I into dt, right? If you integrate this one, this will become again q here. So from here q is equal to, so here limits 0 to 2, that is about the time. You just substitute the value of I, already they have given I is equal to what, that value. Now substitute the value I is equal to, then integrate this one, this already you know this one, x power n by n. If you are integrating this one, x power n divided by n, that is about x power n plus 1 by n plus 1. This is about the integration value here. Now you just mention here t square. If you integrate this one, t cube divided by 3 and 2t square. So integrating this one and integrating this one here is 5t. Now this value, total value here is this one, 3 3 will be cancelled here, 2 2 will be cancelled here again. Now substitute the value of 0 to 2. If you substitute t equal to 2 value, if t equal to 0 means this all three values will become 0. Only thing is t is equal to 2, you just substitute here and add all this value. What you are getting, that answer here is 22. C is nothing but Coulomb, because what you are getting here is total charge flow. That's what they are asking. This is not the current flow of charge. That's what they are asking. So they are asking about Q is what, and the unit is in Coulomb. So remember that in this case, all the units are in Coulomb. So the answer here is 22 Coulomb. Okay, now the next one is if a wire of circular cross section with the radius they have given, that is small r, and moving with a drift velocity is b, when a current flow they have given, I is about the current flow through a wire. Now, what they are asking in this case, the current in the another wire, and the radius here is, they have given here as radius is r by 2, and half of the radius, that is r by 2, and the same material is the same, and drift velocity they have given, drift velocity here is 2v. Okay, now before going to that, we have to know about what you mean by drift velocity. So first, see in the previous picture, the first picture only you can see this one. Drift velocity is mainly depends on the free electrons, number of free electrons in an material, even wire in the metal. This is about the metal wire which is having more number of electrons, but we need to concentrate only about free electrons. So what you mean by drift velocity? Drift velocity is nothing but, this is about average velocity that acquires by the free electrons. See, remember this one, average velocity of the free electrons in the metal whenever you are going to give the current, additional external current. So the drift velocity is mainly depend on additional current. Okay, now see from this one, usually the drift velocity value, that velocity will become a 10 power minus 4 meter per second. That is about a general values here. Okay, now from this one we can find out what is the relationship between the drift velocity and your current. See, electric current and drift velocity they have given, I is equal to NEA into VD, where N is about number of free electrons and E is about the charge of the electrons, and A is about the area of cross section, and VD is nothing but the drift velocity. Already I told this one. For the first case, see here, for the first case in this one, I just mentioned here current here is I1, and n is number of free electrons and the charge of the electron area. So this is about the wire, that is about the circular wire. So you are having the area of the first one here is pi r square. The second one I just mentioned here, current flow in this, the second one here is I2 and area of cross section A2, but here drift velocity is 2v. Here they have given, only assume that this has been v here, but in this case the second one they have given as 2v. Now, here is area, here is pi r square, here r is equal to r by 2 the whole square. Now, from this case, first one I just mentioned, that's like that. Second one here is, see, ne pi r by 2 whole square into 2v. Now, substitute the value in this case. So, from this one I just mentioned here, ne pi into this one here is r square divided by 4 into 2 here, 2 will be cancelled in this case. See, n, this is about charge of the electron, ne pi r square, already we know this one, this is I1 here, and the remaining here is 2. So from this one, I2 here is I1 divided by 2. So I1 you just mentioned here, current flow in this case, I1 here is I. So from this one, answer here is I by 2. Okay. Next one is, if an electron revolves in a circular path of radius here is 0.5 angstrom. At a frequency, they have given new value here is 5 into 10 power 15 cycles per second. Now, next one is what they are asking, the electric current is. So simple one, they are asking about current I is equal to what? That's what they are asking. But additionally, sometimes what they are given here is additional information they have given to make you to confuse little more on this one. Usually we know this one. I is equal to current here is, I here is charge by time, rate of flow of charge, simple, that one is called as current. So from here, charge here is q into, and inverse of time we call it as frequency, I just mentioned as nu here. See, q here is charge of electron, I just mentioned here 1.6 into 10 power minus 19 coulomb, that is about the charge. And frequency they have given, frequency value here is 5 into 10 power 15 cycles per second. That's what they have given here. In this case, from this one, see, you just cancel this one, 10 power minus 19 into 10 power 15, what you are having here is 10 power minus 4. So 1.6 into 5, what you are having here is 8 into 10 power minus 4 ampere. That's the current. But the options, everything what they have given here is milliampere only. So I just mentioned this one. See, this one simply 8 into 10 power minus 3 into 10 power minus 1 ampere current. So 10 power minus 1 you just mentioned here, 8 divided by 10 into 10 power minus 3 ampere. So this one here is 10 power minus 3 ampere is milliampere. 8 divided by 10 is 0.8. 0.8 milliampere is the right answer. Okay. Now, next one is the potential difference between the ends of the wire of resistance. They have given 5 ohm and 720 coulomb of charge. So charge value they have given, passes through the passes through it per minute. So charge per minute they have given. Per minute means 60 seconds, 1 minute. So what they are asked in this questions, they are asking about what is the potential difference between the end. According to, so till now we have seen about the general about current. Now we are going to use Ohm's law. Ohm's law, see here, V is equal to IR. See, from this one, I here is charge by time, q by t into r. Now this one, v is equal to charge by time, charge they have given 720 coulomb of charge, and time 1 minute they have given. You just, in SI unit we always use in seconds, so 1 minute here is 60 seconds, multiply with the 5 ohm resistance they have given. So substitute the value here and cancel it. So 0 0 will be cancelled here, and this one you just cancel here, multiply with this one and divided by here, what you are getting here is 6 volt. That is about the potential. Next questions in Ohm's law. This one here is 3 resistor, 1 ohm, 2 ohm and 3 ohm are connected in parallel. Now understand this concept. One additional point they have given, connected in parallel, and the ratio of current passing through them when a potential difference is applied across the end. So what they are asking in this case, the ratio of current passing through it. Now see one key point they have given, which are connected in parallel. Remember this one in this case. Now if three resistors are connected in series, so important key point we need to remember here is, where the resistors are connected in series, here current is same and the potential difference are differ. Now in this case, see I just mentioned here, for this one here is I, here is, here also the current will be high, here also the current will be high, but in this case the potential difference across the first resistor we can mention here, this one is V1, but in this case the potential difference across the second resistor we can mention this one as V2. Similarly, in the third one, we can mention here, this one here is V3. So the potential difference across each resistor which are connected in series, the potential difference V is differ. But in case of this one, you can observe here, if the resistors are connected in parallel, in a parallel connection, this one you can mention as I1, I2 here, and this one here is I3. Current is differ, but the potential difference you can observe here, there is a battery which can be connected across the resistor, all the resistors are connected in parallel, so here is potentials are same but the current is differ in this case. So remember this one, so these resistors are connected in parallel, so in this case current is differ, the potentials are similar. Now this one, remember these 2 points, current is differ, so we are going to find out the ratio of the current and the potentials are same. Now in this case, according to Ohm's law, V is equal to IR, from here I is equal to V by R. So for the first resistor what we are getting, the current here is I1. Similar, the ratio I1 is to I2 is to I3 here is V1 by R1, V by R2 and V by R3. So all the potentials are same here, so I just mentioned as V will be cancelled here in this case, in case of ratio, because potentials are same. So 1 divided by first resistance here is 1 ohm, 2 ohm and 3 ohm resistance here. Now you just take a LCM, that answer here is 6 is to 3 is to 2. Okay, now next question, in this case, two wires of same material and having the length ratio. So they have given the length ratio here, what they have given the length ratio here is L1 by L2. So because there are two wires, two are difference in length ratio of 2 is to 3 are connected in series, already I have mentioned here, which are connected in series in this case. Hope you remember this one. Potentials are differ, current will be the same. So current I will be the same, I is same and V is differ, remember this point. Next one, the potential difference across the wire for the first wire, what they have given here is, that's what see here, 4.2 volt for the first wire, 3.6 volt for the second wire. Compare the radii, that's what they are asking here. For this one, according to Ohm's law, V is equal to IR, V is equal to, so how you are getting this one, I into OL by A. Now in this case we just find out resistivity or even specific resistance. Resistance and specific resistance relation here is R is equal to L divided by A, where L is length, A is area of cross section. See here, as the length is increases, as length increases, resistance will also increases. Now if the area of cross section increases, here area of cross section increases, here resistance will decrease. For this one you can understand here, see there are a lengthy wire and one is small wire, which is having more resistance here is the lengthiest one, which is having more resistance, smallest one is not having more resistance. Similar area of cross section, this one, this is a big area of cross section I just mentioned here, and this one is thin wire I just mentioned in this case, this is the thin wire which is having more resistance in this case. This one thin wire is having more resistance when compared to thick wire. You can understand here, thick wire should make it should have a more resistance, but the thing is, even for the fuse we are using very thin wire, because fuse, it can easily fuse the one of the important property, but in this case which is having more resistance, that is resist to the current, that's why thinnest wire having more resistance, because area of cross section is inversely proportional. So from this one, R is equal to proportionality constant I just mentioned here, rho L divided by A. where rho is called as specific resistance. For this one, you just mention here I is equal to I into R. Instead of R, I just mention as rho L divided by A. A here is specific area of cross section, rho here is specific resistance, or even you can mention as the same material. In this case, even density will also be the same. For the first one, 4.2 volt I rho L1 divided by area here is 4 pi R1 square. This is 4 pi R2 square here, I rho L2. Now ratio, this one 4.2 divided by 3.6, you just multiply here 10 divided by 10, so 42 divided by 36 will be there. 7 times 60 tables, 7 times and 6 times you can get it here. And this one here is I and I. Here current will be the same because which is in series connection, current will be the same, and even same material, rho also will be the same. So you can cancel over here. For this one, L1 by L2 into C here. See, this is denominator will be there R1 square, L1 by R1 square, and L2 will be there. So L2 divided by R2 square, R2 will come over here, R2 square divided by R1 square. L1 by L2 already they have given 2 by 3. See, 7 by 6. I just mentioned in this case 7 by 6. That one will be equal to, that one will be equal to 2 by 3 into R2 square divided by R1 square. You just take it over here. R1 square divided by R2 square here is the same one, 2 divided by 3 into 6 divided by 7 here. This will be cancelled over here 3 times. So what you are having here is 6 divided by the same one 2 times here, 4 divided by 7. Take a root R1 by R2. What you are getting here is 2 is to 7. Okay. These questions, they have given the relationship between the potential and current graph for a metal wire which is at the temperature, different temperature as shown in the figure. Now, this one, the known value will be always taken in x-axis and the dependent value will be taken in y-axis. What the potential has been given according to the current will be there. They have given this one. There are two different temperature T1 and T2 they have given here. For this one, see, in this case, I just draw a slope line over here. For in this case, see here I just mentioned this one. This is this one I just mentioned as theta 1 here. This one is theta 1 and this one here is theta 2. See, for in this case, you can understand here theta 1 which is greater than theta 2. Simple in this case, this is straight line. For this one I just mentioned here, I just going to find out the slope. Slope we can find out here. M is equal to y by x, or even a tan theta here is. I just mentioned here tan theta 1. In this case, tan theta 1 here is opposite side by hypotenuse here. That is opposite side here is current here. See this one. This is opposite side, and this one is adjacent side. Opposite side by adjacent side. See, I just mentioned here. This is about I divided by. I just mentioned here I divided by V here. V is equal to IR, or even so this one according to Ohm's law, V is equal to IR, or even you can mention here R is equal to, or even 1 by R. That one will be equal to I divided by V. For this one I just mentioned here theta 1 is equal to that resistance I just mentioned as R1 here. Similar in this case, theta 2 is equal to 1 divided by R2. And another one more relation here is, as the temperature increases, the resistance will also increases. So temperature and resistance are directly related. As the temperature increases, resistance will also increases. Temperature decreases, resistance will also decreases. For this one, you just remember here R is proportional to T here. For this one, already we know this one theta 1 which is greater than theta 2 here. So for this one, this is inversely related. The angle, that is slope angle, and the resistance are inversely related in this case. See, tan theta here is, you can mention here, how you can mention this one, tan theta is, will be mentioned as theta 1 here is sine by cos, sine theta divided by cos theta here. If theta is very small, sine theta equal to theta. This is one of the theorem in mathematics, and cos theta will be equal to 1. So sine theta here is theta, theta divided by 1. What you are getting here is theta. So I just mentioned here tan theta 1, I just mentioned as theta 1. Theta 1 is equal to 1 by R1 here. So theta 1 is greater than theta 2 here. This one I just mentioned as 1 by R1 which is greater than 1 by R2 here. I'm sorry. I just mentioned as 1 by R2. For this one you can mention here R2 which is greater than R1. So cross this direction will go here. So from this one, R2 is greater than R1, and R2 is directly proportional here, proportional to T. So I just mentioned as T2 is greater than T1 or even T1 which is less than T2. Even you can mention that one also. So from here, that answer here is T1 which is less than T2.